Hey everyone, and welcome. Today we're jumping into a super cool topic in maths called Arithmetic Progression, or AP for short. It's all about becoming a detective and finding the secret patterns hidden inside numbers. So check this out. Look at these numbers: 2, 5, 8, 11. You can see a pattern, right? It's pretty obvious we're just adding 3 every time. But what if I asked you to find the 100th number in this list? Phew, writing all of them out would take forever. But don't worry, by the end of this, you'll have a kind of superpower to solve that in just a few seconds. Let's get into it. Okay, first things first. Before we can become masters of AP, we need to get familiar with a few keywords. Think of these as the essential building blocks, the foundation for everything else we're about to learn. Word number 1 is sequence. Now, it's basically just a list of numbers, but there are two very important things to remember. First, it's an ordered list. The position matters. And second, it has to follow a specific rule. It's not just a random jumble. Take these odd numbers for example. 1, 3, 5, 7, 9. The rule is simple. Add 2 to get to the next one. Word number 2 is term. And this one is super easy. A term is just any single number in our sequence. So in our list, 1 is the first term, 3 is the second term, and it goes on like that. We even have a little code for it. We use T and a small number at the bottom to show its place, like T1 for the first term. And our third word is progression. Think of it this way. When a sequence has a really clear, definite and predictable pattern, it gets a special upgrade. We call it a progression. It's kind of like a VIP in the world of number lists. Alright, you've got the basics down. Now for the main event. Let's crack the secret code of AP and find out what makes these progressions so special. So here it is, the big secret. An arithmetic progression or AP is a sequence where the jump or the difference between any two numbers right next to each other is always the same. Not sometimes, not most of the time, always. That constant jump is the key, and that fixed jump has a special name. We call it the common difference, and we use the letter D as a shortcut. To find it, you just take any term and subtract the one right before it. And D can be anything. It can be positive if the numbers are going up, negative if they're going down, or even 0, which just means all the numbers in the list are the same. This is really cool because it means you can build any AP in the universe with just 2 ingredients. All you need is the very first term, which we call A, and the common difference D. You start with A, then you add D to get the next one, add D again for the one after that, and you can keep going forever. And now the moment you've been waiting for. This is the magic formula. This is our superpower. This tiny equation lets you find any term you want without writing out the whole list. Want the 100th term? The 500th? No problem. It's like a time machine for numbers. The term you want, Tn, is equal to A plus, and listen carefully, n minus 1 times D. Let's put this magic formula to the test. Remember our sequence 2, 5, 8? Let's find the 10th term. First, we identify our ingredients. A is the first term, so that's 2. D is the common difference, which is 3. And N is the position we want, which is 10. Next, we just plug those into the formula, so we get 2 plus 9 times 3, which is 29. And boom, the 10th term is 29. See? So much faster. But wait, there's more. What if you wanted to find, say, the third term from the end of a long list? You don't have to count backwards. There's a formula for that too. If you know the very last term, we call that L. You can just work in reverse. Instead of starting at A and adding D, you start at L and subtract D. So you can travel forwards or backwards in the sequence. Okay, so now we're pros at finding any single term. That's great. But what if we need to add up a bunch of terms in a sequence? This is where we shift from just looking at lists to finding the sums. First, a quick vocabulary check. What's the difference between a sequence and a series? It's simple. A sequence is the list of numbers, with the commas in between. A series is what you get when you change those commas to plus signs and actually add them all up. So sequence is the list, series is the sum. Now, adding up 100 numbers one by one would be so boring. But of course, there's a shortcut. We have another magic formula, a super calculator for finding the sum. We call the sum of n terms Sn. And this super cal comes in two versions. It's all about using the right tool for the job. If you know the first term a and the common difference d, you can use the first formula. But if you know the first term a and the last term l, the second formula is a huge shortcut. It's so much faster and easier. Let's try that shortcut. Say we want to add 2, 5, 8, 11 and 14. Okay, a is 2, the last term l is 14 and there are 5 numbers so n is 5. We pop those into our simple formula 5 upon 2 times 16 and we get 40. Imagine doing that for 100 terms. This formula is a real lifesaver. Okay, let's switch gears to something really simple but super useful. What if you just want to find the number that sits perfectly in the middle of two other numbers? This middle number is called the arithmetic mean. Now that sounds fancy, but guess what? It's just the average. You've been doing this for years. To find the mean of two numbers a and b, you just add them up and divide by 2. It's the perfect balancing point between them. Alright, you've learned all the basics, all the main formulas. Now it's time for a pro-level trick. This is a clever little technique that will make solving certain problems so much easier. Check this out. If a problem says the sum of 3 terms in an AP is, don't pick your terms as a plus d and a plus 2d. No. The smart way is to pick them as a minus d, a and a plus d. See why that's so clever? When you add them up, the minus d and the plus d cancel each other out. They just vanish and you're left with a super simple 3a. This symmetric trick works for 4 and 5 terms too, and it makes the calculations a breeze. Wow, we have covered so much today. Let's do a quick fire recap. Ready? 1. An AP has a constant common difference d. 2. We can find any term using our magic Tn formula. 3. We can add up all the terms with the Sn supercalculator. 4. The middle value is just the average, the arithmetic mean. And 5. We know the pro trick of choosing symmetric terms to make our lives easier. And that's pretty much it. You've done it. You literally have the complete toolkit now. Every formula, every trick you need to understand and solve any problem about arithmetic progressions that anyone throws at you. So I leave you with a final thought. Now that you know how to decode these number patterns, start looking for them everywhere. The way the seats are arranged in a stadium, maybe the way your pocket money increases every year. What other things in the real world follow these rules? The world is full of patterns, and now you have the skills to understand their secret code. How cool is that? See you next time.